It's time to introduce the concept of a vector. Now this is something that mathematically has a very precise definition. And that definition is pretty much shared by mathematicians, computer scientists, and physicists, although all three types of researchers think about them in a slightly different way. We're not going to go into that rigorous definition. Instead, we're going to use a much more simplified idea of what a vector is. And the reason is because for this class, vectors are going to be very important for a lot of the calculations that we're doing. But we don't need the very mathematically rigorous version that's well beyond the scope of what we're going to care about in this class. So this is the first topic that we're introducing that we know we're not really introducing it in the precise way, but we're doing it in a way that it's easy to understand and that we'll be able to use it. So with that said, there are basically kind of two types of numerical quantities we're going to deal with. So the first are scalars. And a scalar, you can just think about as a number, usually with a unit, right, if we're talking about a physical quantity. So for example, this would be something like distance, right? So like 5 kilometers is a scalar. Speed, right? So, 50 kilometers per hour would also be a scalar. Mass, right? So something like, 150 kilograms would be a scalar. Temperature, right? So something like, 273 Kelvin would be a scalar. So then what's a vector? A vector is basically a magnitude and a direction. The other way you can think of it is as a collection of numbers. That's probably closer to the way that like a computer scientist thinks about vectors. And so what that means, so distance now is going to become displacement. So this would be something like 5 kilometers north, right? So now we're giving a direction in addition to the distance. Speed will become velocity. Right, so now we have something like 50 kilometers per hour east. Now there isn't a direct vector quantity for mass. So instead, the closest thing we have is a force, right? So if we combine the mass with an acceleration, then that would give us a weight. So for example, 130 newtons down, and then there is no vector for temperature. And of course there are other quantities that can be vectors as well. And in the upcoming videos we'll be talking about how we can represent vectors both kind of mathematically and graphically.